So welcome back, Level 1 NCEA Physicists, continuing on with the mechanics external, and today looking at our final subtopic, energy transfers. So as we've learned, energy is required to do work. Okay, you have to use energy to push a force over a distance. And fuels are burnt to release energy. That's why we use fuels. And in terms of planet Earth, the sun is where we get our energy from. So there are many forms of energy, which we will briefly go through today in today's lesson. And so we can start off with the thermal or heat energy, and that is the energy of an object due to its temperature, the amount of kinetic energy the object has. We have light energy, and that's the light from the sun. Okay, it's the form of something called electromagnetic radiation. We have electrical energy, which is from batteries, for example, and it's the energy that is transferred in electrical current. So electrical energy is transferred into light energy, for example, for the bulbs we see in our image. Then we have sound energy, when this is the energy in the form of a sound wave, okay, which we use for our speakers and our AirPods. Then we have kinetic energy, which we're familiar with. This is the energy of moving, okay, and remember that the equation is half mv squared, half the mass times the velocities. Then we have chemical energy, and that's the energy which happens to be stored when chemical reactions take place. Okay, so for example, inside a battery, or even the food you eat, that's chemical energy as well. That's why we eat food, to get energy so we can do things and do work. And sources of energy can include the fuel, batteries, and food, as just previously mentioned. And we also have nuclear energy, and that's the energy released when nuclear explosions occur or when it's more controlled in nuclear power reactors. And this is actually the source of the sun's energy, nuclear fusion. And we also have the different forms of potential energy. And the potential energy we look at primarily in level 1 physics is gravitational potential energy, which we've already looked at, which is the mass times the gravitational field strength times the height of the object. And later we also look at elastic potential energy in level 2. And this is the energy which is stored in a spring, or say another example would be in kind of an object like that. Basically a bow, an arrow. Okay, so the bow would have elastic potential energy, or a slingshot. There we go. That's finally got the word. Okay, and this is known also as strain energy. And just to remind you, the units of energy are joules. So here we have an apple, so if we lift it upwards by a meter, this requires 1 joule of energy. And we can also interlink, so 1,000 joules is a kilojoule, and 1 million joules is a megajoule, capital M. So be careful in exam questions when they have those numbers in front, those prefixes. You have to convert it to the appropriate number of joules. So the key important point for this lesson is that it's the concept of the conservation of energy. So energy cannot be created nor destroyed. It can only be transformed from one form of energy into another form. So for example, converting electrical energy into sound energy for a speaker system. Okay, and it means also that the amount of energy in the universe remains constant. Okay, so an example here of an energy transfer is between kinetic and potential energy, which is primarily what energy transfers you'll do in level 1. Okay, so at the top of the pendulum, okay, is going to have maximum potential energy, and at the bottom it's going to have minimum kinetic energy, and all that potential energy, and all that potential energy is being converted into kinetic energy. Okay, so going through it again, at the top, maximum gravitational potential energy, at the bottom, minimum gravitational potential energy, and at the top, minimum kinetic energy and maximum kinetic energy at the bottom. Okay, so the total energy stays the same, but the sum of the potential energy and electrical kinetic energy, basically the ratio of kinetic to potential energy changes. Okay, so basically if there's no air resistance, the energy total will equal EP plus EK, potential energy plus kinetic energy, and also potential energy will equal the total energy of the system minus the kinetic energy, and conversely, the kinetic energy will equal the total energy of the system minus the potential energy. Okay, and finally, in terms of useful energy and wasteful energy, so basically useful energy is the energy we want, and other forms are known as wasted. The wasted energy goes around to its surroundings. Okay, so usually the wasted energy is the form of heat or sound energy. Okay, so for example, braking systems, you want to kind of convert your kinetic energy into friction, so it stops, okay, through friction, and that's converted into wasted energy in terms of heat energy as well. Okay, so that's the concept of useful and waste energy.